Subsea BOP equipment is similar to a surface stack. There are, however, some very important differences. This section discusses these differences. Subsea stacks attach to the wellhead on the sea floor. Meanwhile, the rig floats on the water, hundreds or thousands of feet or meters above. Major parts include the Subsea BOP stack. This is a lot like a surface BOP stack. Other parts are different, however. Here's the flexible or ball joint, the marine riser with the choke line and kill line, guide lines, the telescopic joint with riser tensioners, the hose bundle, and 2 control pods. The driller controls the Subsea BOP valves from an electric BOP control panel on the rig. The Subsea hose bundle carries the control signals and the hydraulic fluid from the rig down to the control pod and selected Subsea BOP valves. Marine riser pipe is special pipe and fittings. It seals between the top of the Subsea BOP stack and the drilling equipment located on the floating rig. Crew members run the drill string into the hole inside the riser pipe. The riser pipe also conducts drilling fluid up to the rig. Manufacturers attach 2 smaller pipes, called the choke and kill lines, to the outside. Crew members use them to control the well during a kick or special operations. Guide lines guide and help position equipment such as the BOP stack to ocean floor. The flexible joint cuts down on bending stresses on the riser pipe and BOP. The telescopic joint compensates for the vertical motion of the floating rig. Crew members also attach the riser tensioning system to it. Riser tensioner lines support the long riser pipe. The riser and guide line tensioners put constant tension on the riser pipe and guide lines. This tension suspends the riser pipe. It also compensates for the movement of the rig caused by wave action. Riser tensioner systems usually range in capacity from over 300,000 to almost 1 million pounds. That is 135,000 to over 455,000 kilograms, with 50 feet or 15 meters of wireline travel. They utilize up to 12 compression-loaded tensioners that use air pressure for compensation. Drill string valves stop fluids from flowing up the drill string. Often, if the well kicks with a bit off bottom, formation fluids flow up the annulus and up the drill string. Crew members close the drill string valves to stop the flow in the string. If the Kelly is made up, they can close the upper or lower Kelly cock. If the Kelly is not made up, then they can install a full opening safety valve in the top of the drill string. An inside blowout preventer, or IBOP, is a one-way valve, a check valve they can install in the drill string. One type of IBOP is a float valve that is sometimes made up in the drill string near the bit. It prevents backflow up the drill string. Another type of IBOP is the drop-in valve, or DIV. It's dropped into the drill string and falls to a special landing sub that is usually located near the top drill collar in the drill stem. It allows the driller to pump mud down the string, but the check valve will not allow influx fluid to flow up the string. Another type of inside BOP is the heavy-duty check valve, or gray type valve after one company that makes it. It's a plunger check valve that crews stab in the drill pipe at the surface. It's usually used during stripping operations. Stripping is when the crew lowers the pipe in the hole while the BOPs are closed and under pressure. An upper Kelly cock is located above the Kelly. The upper Kelly cock normally serves as a backup to the lower Kelly cock. If the lower Kelly cock failed, Crew members would use a special operating wrench to close the upper Kelly cock. The closed upper Kelly cock prevents further flow. It protects the equipment above the Kelly from high pressure flow. Usually, crew members close the lower Kelly cock if a kick puts risk on equipment above the Kelly. They make it up in the bottom of the Kelly. A crew member uses a special operating wrench to close it. The crew can also close the lower Kelly cock to keep mud from falling out of the Kelly when they break out the Kelly to make a connection. A cock is another name for a valve. Cock is short for weathercock, which is an English term for valve. Here's a full opening safety valve. If the Kelly is not made up in the drill string and flow occurs, crew members can insert the safety valve in the drill string. This procedure is called stabbing. A full opening valve has as large an inside opening as possible. When fully open, flow from the drill pipe passes through the valve with no additional restriction. This relatively large opening allows the crew to stab the valve against pressure coming out of the drill string. The crew picks up the safety valve by its lifting handles. They make sure it is fully open and stab it into the drill pipe. Then they screw it into the pipe. Finally, they use a special operating wrench to close the valve and shut off flow. Drillers should make sure the rig has the right crossover subs handy on the rig floor. Crew members should be able to make up the safety valve in any drill string member coming out of the rotary. For example, if a drill collar is in the rotary, the safety valve's threads may not match the drill collar's threads. They will need the right crossover sub to make it work. This well is taking a kick. To shut it in, choose one of the two valves you see here, a one-way safety valve and a full opening safety valve. Click on the valve you want to use. Hold your mouse button down and drag the valve to a drill pipe. The full opening safety valve is the correct valve to use in this situation. It can be stabbed on the drill pipe while it's open, and then closed to shut in the drill string. You're not done yet though. The annulus hasn't been sealed, so the well is still not fully secured. Click on the correct preventer on this BOP stack that should be closed first. That's right. The annular preventer is closed first. Good job. You've successfully closed in this well. Float valves also prevent flow up the drill string. Crew members place a float valve in a sub, a special drill string fitting, just above the bit. One type allows mud to be pumped down, but shuts against upward flow. Under normal conditions, pump pressure moves drilling mud through the open one-way valve. An influx of formation fluids from below causes the float valve to close. This prevents further flow up the drill string. Match these components of the Subsea BOP stack and marine riser system with their function. What type of preventer is this? A. Annular preventer. B. Pipe ram. C. Blind ram. D. Blind shear ram. During the drilling operation, formation fluids are kept out of the annulus by the A. BOP stack, B. Pipe ram, C. Choke manifold, D. Drilling mud. Which one of these photos shows where the hydraulic fluid is stored to operate the BOP valves? Which of these does not use a surface BOP system? A. Semi-submersible. B. Submersible. C. Platform rig. D. Jackup rig. Which of these valves is located just above the bit? A. Upper Kellycock. B. Lower Kellycock. C. Full opening safety valve. D. Float valve. Unusual changes in mud level while tripping can be monitored at A. The mud pit. B. The trip tank. C. The BOP stack. D. The BOP control panel. When the preventers are closed, well fluids flow to the A. Choke manifold. B. Accumulator. C. Trip tank. D. Flare pit. If the Kelly is not made up on the drill string and flow comes up the drill string, what can be used to stop the flow? A. Lower Kellycock. B. Full opening safety valve. C. Pipe ram. D. Annular preventer. Which one of these is an IBOP? Identify this piece of equipment. A. Accumulator. B. Choke manifold. C. BOP stack. D. Mud gas separator. This tension suspends the riser pipe. It also compensates for the movement of the rig caused by wave action. Riser tensioner systems usually range in capacity from over 300,000 to almost 1 million pounds. That is 135,000 to over 455,000 kilograms, with 50 feet or 15 meters of wireline travel. They utilize up to 12 compression-loaded tensioners that use air pressure for compensation. Drill string valves stop fluid.